big is the difference between mechanical hard drives and solid-state drives? First, from a storage structure perspective, they are completely different. Mechanical hard drives use magnetic platters to store data. The platter of a 7,200 RPM mechanical hard drive is divided into over 500,000 tracks. These tracks are further divided into multiple sectors. Our data is stored in these sectors. To read and write data stored in sectors, mechanical hard drives must rely on the actuator arm. One end of the actuator arm is an electromagnet. When the electromagnet is powered, it generates force. This drives the actuator arm to move back and forth over the high-speed spinning platter. The tip of the actuator arm is a read-write head. When we magnify the magnetic head and disk, we can see the disk is composed of many magnetic units. The back of the magnetic head consists of a coil. When the coil is energized, it generates a magnetic field. Each time data is written, the magnetic units on the disk become magnetized by the magnetic field. Different data corresponds to different magnetic field directions. Reading data works similarly based on changes in the magnetic field. The read-write head can detect different binary data based on the strength of the magnetic field. Solid-state drives use flash memory chips to store data. When we magnify the storage chip, we can see it. Inside the chip is a massive 3D flash memory cell array. These flash memory cells are stacked 100 layers high. Horizontally 40,000 columns, vertically 50,000 rows. Data in solid-state drives is stored in billions of these storage cells. Storage cells are formed by concentric circles. The interior contains multiple layers. This is a cross-sectional diagram of a storage cell. Storage cells are divided into gates, charge traps, and channels. The charge trap is used to store electrons. When we save files to the hard drive, it is equivalent to injecting electrons into the charge trap of the storage cell. One such cell can store 8 different binary data values. Then, based on the electrons in the charge trap and the voltage applied to the gate, data can be read. At this point, the first advantage of solid-state drives emerges. Mechanical hard drives depend on the speed of mechanical structures, especially the rotational speed of the platter. Before reading data, the actuator arm must first move to the corresponding track, then wait for the sector to rotate into position before reading can begin. This causes a delay of about 10 milliseconds. Solid-state drive storage uses electrons. The speed of electrical signals is certainly far superior to mechanical speed. Most mechanical hard drives can achieve speeds of 100 to 200 megabytes per second, while SATA 3 solid-state drives can reach speeds of 500 megabytes per second. Additionally, solid-state drives produce no noise. Mechanical hard drives produce significant noise because they require high-speed disk rotation. Furthermore, solid-state drives can typically be made very compact because they use flash memory chips. They are commonly used in laptops. Mechanical hard drives are relatively large due to their complex structure. They are commonly used in desktop computers. However, mechanical hard drives also have several advantages. Mechanical hard drives are more affordable. For the same capacity, mechanical hard drives cost about 3 times less. Additionally, solid-state drives have program erase cycle limitations, so their lifespan is shorter than mechanical hard drives. Finally, once data is lost on a solid-state drive, it is very difficult to recover. While data recovery on mechanical hard drives is relatively easy,